Hello, in this video we want to look at sedimentary rocks and how they're formed. Ben Carlson in his video is going to talk about weathering of other types of rock, which will create the sediment that is necessary to create sedimentary rock. Before we get going too far, we want to kind of talk about how we size the sediment that forms sedimentary rock. This is a very abbreviated table. There's a longer table in the text which kind of breaks these down even farther. But kind of the basics, and these are called clasts, these different categories of sediment. The largest being boulders, 256 millimeters and up, which would be anything from the size of a toaster to a small house. Okay, or even bigger. There is no upper limit on how big a boulder can be. Next up is cobbles, which would be anything from the size of like a tennis ball up to that toaster. And then next would be pebbles or granules, and that'd be like anything from the end of your ballpoint pen on up to a tennis ball. And then the next three are all quite a bit smaller. Sand can be anything as large as the end of the ballpoint pen, all the way down to just really gritty feeling particles. Typically, this is quartz. As Ben probably talked about in his video, the quartz doesn't really weather chemically, so you end up with a lot of quartz sediment as sand. And then on down from there, smaller pieces, you get silt, and even smaller than that is clay. The text kind of talked about how you can tell the difference between silt and clay and sand. Sand feels really grainy between your fingers, and silt and clay both feel really smooth between your fingers. And the text suggests that you can tell that material is clay rather than silt if you taste some of it. If it feels smooth in your mouth, then it's clay. If it feels rough in your mouth, then it's silt. But it's going to feel smooth in your fingers either way. So that's just kind of the building blocks of sedimentary rock. It's all of these particles that have been weathered away from other types of rock and then carried to a new location. One other thing that the text talked about was depending on the size of these different clasts. If you drop, say you drop a pebble or a granule into a glass of water, it's going to sink right to the bottom fairly quickly. There's gravity pulling it down, and that frictional force of the water is not going to be enough to really slow it down very much. But if you start dropping in, say, silt or clay, then those particles are so small that the gravitational force is a lot more similar to the frictional force pushing back up, and so they're going to sink a lot slower. And sometimes with the clay, they'll hardly sink at all, just because the frictional force is so low because it's based on the surface area, and the surface area of these tiny particles compared to their mass is not very much. So the gravitational force and the frictional force will actually kind of balance out, and the clay sediments won't actually sink to the bottom, whereas sand will sink. It might just take a little bit longer, and the granules will sink pretty much straight to the bottom. The process where these different sediments become sedimentary rock is called lithification. So, like I said, they get weathered away from these other rocks through different processes, and then they get carried to a new location. And typically, these only form in very wet locations because we need a way to carry the sediments away, typically in streams or running water. And then they deposit all of these sediments together, and we end up with just a kind of a loose layer of this sediment, which then gets compacted back together as more and more gets piled on top of it. The weight increases, and the sediment really piles together. And then, as the water's running by, it deposits other trace minerals, and they start to cement together. The minerals fill in all of the little nooks and crannies in between the larger sediments, and we end up with a solid rock. So it's a combination of all of these weathered sediments that get deposited together and then compacted down by layers and layers on top, and then all of the nooks and crannies get filled in by other minerals, and they cement together. So it's like I said, it typically happens in streams and marine locations. because you kind of need that water to deposit the extra minerals to cement everything together. And that's not to say that they still have to be wet locations, but at one point, at the time when the rocks were formed, they would have been wet locations. And there are just a whole host of different kinds of sedimentary rock formed this way. We can kind of split it up into two major categories. We've got clastic sedimentary rock, which are made up of those clasts that we went over before, the different sizes of sediment. And that's more where they get compressed together, and then all the nooks and crannies get filled in with other trace minerals. The other major kind is chemical sedimentary rock, and that's where um, much smaller um, much smaller materials get deposited together and usually precipitating out of the water, and then they precipitate out enough that they form layers and form a rock. Just going to go through some different types here real quick. Um, do some classic ones first. Mud rock is just classified as being more than 75% silt and clay, so it's fairly smooth. And it's just got some larger clasts mixed in. But to be mud rock, more than 75% of it has to be silt and clay. So very smooth textured, even when it breaks. Most of the surface is smooth just because the pieces making it up are so small. Coal is another one that we've all heard of. Coal is almost in a category of its own, being biological in origin, but it's just compacted and partially decayed plant matter. So wherever we have coal deposits, at one point in the past, there would have been tropical conditions to allow for the buildup of all that organic material. Next one is sandstone. It's mostly sand with some other rock fragments mixed in. Okay, so it's very, very rough sort of sort of stone, just because most of the particles are sand, and typically fairly fragile. Conglomerate is made up of mostly rounded clasts that are larger than the granules, so that'd be larger than the end of the ballpoint pen, so larger ones all the way up to fairly big ones. And they are rounded, just meaning they've been carried farther in the water. All the edges have been rounded off, so they've been weathered more. And if they're not weathered as much, what's called breccia. It's the same idea. We're the same sizes of clasts, but they're just more angular. They've been not carried as far and not rounded over as much. A couple of examples of chemical sedimentary rocks. Limestone is a big one. It almost exclusively is formed in the oceans, and it's made from carbonate fragments from organisms that draw the calcite out of the water and make their shells, and their like coral is a major contributor of these calcite fragments. They break down and then they settle in layers on the floor of the ocean and eventually form limestone. Similar to that is chert. It's just made from mostly silica from other organisms that don't use calcite for their outer shells. And again, we just get a layer of these that settle on the bottom of the oceans and compact down to form this rock called chert. A lot of times chert and limestone are found together in layers. The last kind of chemical sedimentary rock I want to talk about is evaporites, and that's from situations where there's water that evaporates and leaves behind all of its trace minerals. So over and over again, the water comes in, deposits some evaporites when it evaporates, and we end up with these layers. One really common example of this would be like the Bonneville salt flats, where that lake dried up and all of the salt deposits left over would be considered evaporites. Depending on where it forms and how much it got compacted after that, kind of dictates how the form of the stone and what sort of minerals were in the water when it evaporated. So in summary, these sedimentary rocks, they're formed from the pieces of the other rocks that get weathered either mechanically or chemically, and then carried away from the source and deposited, typically in waterways. So they get carried away, deposited in enough depth that they compact down, mineral cement between them, and we get all these different kinds of um, sedimentary rock depending on what type of rock was weathered and what type of minerals did the cementing, and just the conditions around where the rock was formed. There's just a huge variety of materials and characteristics of all these sedimentary rocks. Thanks.